The applications of coordination compounds in chemistry, biology, and technology are many and varied. They play a vital role in analytical chemistry, metallurgy, biological systems, industry, and medicine. Let us see how. Let us start with the applications of coordination compounds in analytical chemistry. Coordination compounds find application in qualitative as well as quantitative chemical analysis. If you look at the qualitative methods of analysis, complex formation is of immense importance in the identification and separation of most inorganic ions. For example, when copper sulfate solution is mixed with aqueous ammonia, a deep blue complex soluble in water is formed. This reaction is used to detect cupric ions in the salt. Similarly, the separation of silver ions from mercurous ions in the first group of analysis is based on the fact that while silver chloride forms a water-soluble silver-ammonia complex with ammonium hydroxide, mercurous chloride forms a black insoluble complex. There are numerous reactions in quantitative analysis where complexes are formed. For example, the formation of a scarlet red complex with dimethyl glycoxime is the basis for the detection and estimation of nickel 2+ ions. Similarly, the hardness of water is estimated by titration with the sodium salt of EDTA. During titration, the calcium and magnesium ions in hard water form the stable complexes calcium EDTA and magnesium EDTA. These ions can be selectively estimated due to the difference in the stability constants of calcium and magnesium EDTA complexes. Now let's see the application of complexes in metallurgy. Noble metals like silver and gold are extracted from their ore by the formation of cyanide complexes. Dicyano-argentate 1 and dicyano-aurate 1. The metals are displaced from the complex in the solution by zinc. Cyanide complexes also find application in electroplating. For example, in the electroplating of silver, large amounts of silver are held as a complex, potassium dicyanoargentate 1. This provides very little, but all the silver necessary for electroplating. Thus, the articles electroplated with silver or gold are much smoother than those electroplated from a solution of simple metal ions. Metals can be purified by the formation and subsequent decomposition of their coordination compounds. For example, nickel can be purified by its reaction with carbon monoxide to form the volatile complex tetracarbonyl nickel 0, which is decomposed thermally to yield pure nickel. Naturally occurring coordination compounds are vital to living organisms. Metal complexes play a variety of important roles in biological systems. For example, chlorophyll, the pigment responsible for photosynthesis, is a coordination compound of magnesium. Hemoglobin, the red pigment of blood that acts as the oxygen carrier, is a coordination compound of iron. Vitamin B12, cyanocobalamin, the anti-pernicious anemia factor, is a coordination compound of cobalt. Many enzymes that regulate biological processes are metal complexes. For example, carboxypeptidase, a hydrolytic enzyme important in digestion, contains a zinc ion coordinated to several amino acid residues of the protein. Another enzyme, catalase, which is an efficient catalyst for the decomposition of hydrogen peroxide, contains the iron porphyrin complex. One of the applications of coordination compounds is their use as catalysts for many industrial processes. For example, in the hydrogenation of alkenes, a complex metal catalyst, tris-triphenylphosphine rhodium-1 chloride, which is also known as Wilkinson's catalyst, is used. Similarly, another complex metal catalyst, known as Ziegler-Natta catalyst, which is a combination of titanium tetrachloride and triethyl aluminium, is used in the polymerization of ethene. In black and white photography, the unreacted silver bromide on the film dissolves in a dilute hyposolution due to the formation of the complex sodium dithiosulfato-argentate 1. Coordination compounds are also used in medicine. British anti-Lewisite, or BAL, is used as an antidote for arsenic poisoning. Similarly, EDTA is used to treat lead poisoning. Toxic proportions of copper and iron in plants and animals are removed by using the chelating ligands D-pencilamine and desferrioxime B via the formation of coordination compounds. Some coordination compounds of platinum are effective in inhibiting the growth of tumors. For example, cisplatin is used in the treatment of cancer.